Welcome! Now you know that thing you're always asking me about, when are we ever going to use this? Well, funny thing happened. Went to Pizza Hut last night and they said we've stopped serving our pizzas in 11, 12-inch diameters. We started selling them in terms of area in square centimetres. So our pizzas come in 30 square centimetre areas, but we can only slice our pizzas in 60-degree slices. So what area will your sector of pizza be, Mr. Amps? Please can you... Oh, no. No, wait. No, that never happened. Let's solve it anyway. It'll be fun. So what we'll have a look at today is we're going to work out the area, not of the whole circle, but of a sector. And then we'll do a similar thing with the arc length. Okay, so hopefully you've watched the last couple of videos and you know what I mean when I'm talking about a sector. And hopefully you watched the last video and you know what I mean when I'm calculating that, or you know how to calculate the whole area and the circumference of the circle, the distance all the way around the outside. Okay, if you have, then you'll be able to tell me that the area formula we're going to need is area of a circle equals pi r squared. And you'll be able to tell me that the circumference formula that we need is circumference equals either pi d or, more useful here, 2 pi r. So let's get started with the area. So area, and what we're going to try and do is calculate the area, not of the whole circle, but of the shaded blue sector. So we want the area of a sector. Okay, now we know the area of the whole circle, it's pi r squared. And you might already be able to spot, well, we've got 60 degrees. Now, what's the total number of degrees in the whole circle? In the whole circle, all the way around, including the last little bit there, we've got 360 degrees. Okay, so we've got 60 out of, if you like, 360 degrees. And you might already be able to spot, hang on a minute, that's 60 degrees. That's 1/6 of this circle. So if I go dot, 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 dot. Okay, it's as if I've broken that circle up into 6 pieces, and the blue shaded sector is 1/6 of the circle. And that's really going to be the key to getting these questions right. So what have we done? How have we got that 6? 1/6. Okay, we've said, right, well, we've got 60 degrees. Oh, we've gone to red. Let's keep it blue for the area. We've got 60 degrees out of a total of 360. So this here is the fraction of the circle that's shaded. It's what fraction of the circle is shaded. So 60 360ths is that fraction. And I want what fraction of the whole circle. Well, remember we can always change of with a times. I want what fraction of the area of the whole circle. So what fraction, what on earth are you doing there, Aroa? What fraction of the whole area of the circle? What fraction of the whole area is shaded? So what's the area of the whole circle? Well, we know that, it's pi r squared. Okay, so I need to do this fraction times my whole area, pi r squared. Okay, we can simplify this fraction. We've got 6 over 36, we can cancel those zeros, times pi r squared. And I know in my diagram that we've got a radius of 8. We'll assume that's centimetres. So I've got pi times 8 squared. Again, I can simplify a bit more again. I can say, well, 6/36. I can divide the numerator and the denominator by 6. We'll get 1/6. Oh yeah, that's what we said before. Okay, this is 1/6 of the whole area. So 1/6 times pi times 64. Now we could do that in our heads. We could work that one out, but let's pop the calculator up. Okay, what are we going to do? Okay, right, well, we've got some choices. Let's clear that. Okay, we've got 1/6. Let's make it look exactly like it does on the screen for a start. So we want 1/6. Okay, now I need to be careful here not to put a multiplied by straight away, because that's going to give me that multiplied by on the denominator. So I want 1/6. Let's delete that. So you move our purple arrow button to get the cursor over there. Then I can go for my multiply. So 1/6 multiplied by pi. Now on my calculator I want shift and the times 10 to the power off button at the bottom. So 1/6 times pi times 64. Okay, we'll press equals and we get 32/3 of pi, 32 pi over 3. Okay, now sometimes we might want to leave that pi in there, but let's S to D it, get a normal decimal, so to one decimal place we've got 33.5 square centimetres. So our area is 33.5 5 square centimetres. Okay, it's an area, so centimetres squared. Okay, now you might prefer, instead of doing that calculation that way, to think of doing the pi times the 64 first. So pi times 64, or press equals, just to do it. Okay, now rather than timesing, multiplying by a sixth, that's exactly the same as dividing by 6. So this time we've done the pi times the 64 first, then we'll divide by 6. We get the same answer. Alright, so just remember, multiplying by a sixth, that's the same as dividing by 6, whichever calculation you prefer. Right, so we've got the area of the sector. It's what fraction of that area of the whole circle is shaded. Alright, now let's try the circumference. Okay, not the circumference. Right, the circumference would be the whole way around the perimeter. What we're going to do is we're going to calculate the arc length. That's a terrible curve. That length there. But we're going to use exactly the same method. So we want the arc length of that sector. Okay, what's the arc length of that sector? So we use the same technique again. Okay, we want what fraction of the entire circumference is that arc length? Well, it's the same. It's 60 over 360. Okay, it's 60 360ths. We're going to do exactly the same thing. So we've got that fraction of multiplied by. This time we want our circumference. We want what fraction of the whole circumference. So we need our 2 pi r formula this time. Alright, well we know that 60 over 360 simplifies to 1/6. And we know we've got times 2 times pi times 8. That's our radius again. So again, we could do this one without the calculator, or we could do it with. So let's go for the fraction method. 1/6. 1/6. Move that across. Multiplied by 2. Oh, I've put my pi in first. Sorry. 2 pi times 8. It's just 1 multiplied. Multiplied by 8. Okay, so what do we get? Right, we get 8 pi over 3, or 8/3 of pi. That's S to D it. Okay, so to one decimal place, this time I get 8.4. So my arc length is 8.4. Is it 8.4 square centimetres? No, because this time we've just got a length. This is a distance around the edge of that circle. So we have 8.4 centimetres. Okay. Shall we have a go at another one? Oh, I think we should. Okay, let's try this one. So this time our circle's got a radius of 6, and we'll assume it's centimetres. And we've got an angle subtended, if you want to be posh, of 75 degrees. The angle inside that sector is 75 degrees. Okay, so we want to know what's the area of that sector. Okay, so the area of the sector. Okay, it's exactly the same thing. What fraction of the circle is shaded? Well, it's 75 360ths. And we want to know what fraction of the whole area, well, that's pi r squared, is shaded. Okay, so that's our starting point. Right, before we calculate that, before you try and calculate it, let's do the arc length. What if we want the arc length of that sector? Arc length of a sector. Believe it or not, that's an E. Okay, arc length of sector. Okay, so again, that's that length there. Right, okay, we want what fraction of the whole circumference is that arc length? Well, again, it's 75 360ths. 360ths? 75 360ths. We want that fraction of my circumference, and that's our 2 pi r. So before I put some numbers in, okay, pause the video, have a go at those calculations, okay, check what you get, okay, and then make sure they match up. Pause. Okay, how do we do? Let's have a look. So area of the sector, what do we want to do? Not that. Okay, we want 75. Let's do it again. We want 75 divided by 360. Right, no, I'm using a different method this time. Okay, we could put that in as a fraction so it looks like a fraction. Press equals. Okay, we get that as our 75 360ths. We then want to multiply that by pi and multiply by r squared. Well, 6 squared, I think that's 36. But if we're not sure, we could always put 6 squared. Okay, so I get 15 pi over 2, or 15 halves of pi. Okay, so to one decimal place, S to D at 23.6. So 23.6 square centimetres. If you got that, well done. 23.6 square centimetres. Alright, what about the arc length? Right, what do we got? So we want 75, let's do it the other way this time actually. 75 360ths, whichever way you feel more comfortable with, but make sure we move that cursor across, multiplied by 2, not 22, 2 times pi times the radius, which was 6. What do we get? 5 pi by 2. So to one decimal place, I make it 7.9 centimetres. So we've got equals 7.9 centimetres. If you got that, fantastic. Okay, let's try one more. Slidey slide. Right, this time, using exactly the same method we have done so far, what I'd like you to do is calculate the area of the blue sector. But calculate the arc length of the white sector. Okay, so just to clarify, you're working at the area of the blue sector. That's just like we've done it before, the area of that blue part there. But the arc length, slightly different. Rather than the sector with 135 degrees, I want you to work out that arc length. Okay, that length there, the arc length of the white sector, the major sector. Okay, good luck. Pause the video. Answers will flash up at the end. Okay, how'd you get on? Hopefully you tried it before you just played on. Area of the blue sector, I got 169.6 square centimetres to one decimal place. And the arc length of the white sector, that should be one decimal place as well. 1 dB. Right, I got 47.1. Now what was the trick here? Right, the trick with the arc length of the white sector is first of all we've got to work out this angle. It's this angle we need here to tell us our fraction. And that angle I made 225 degrees. Okay, and to get that, I said, well, 360 minus the 135 gives us the angle we need for our fraction. So be careful. If you know the angle in the opposite sector, okay, you might need to subtract from 360 first. Okay, if that doesn't make sense, give me a shout in class. Make sure you've had to go first. Well done. Hope that was useful.